Today, Guts and Bolts is coming to you from one of the world's engineering wonders, the Panama Canal. This episode, I'll see how the incredible lock system works and get a rare look inside the canal control house where they let me get hands-on. I also get behind the wheel of another beast of burden, the mighty tugboat, which literally runs circles around all other ships. Finally, I get under the hood of a Mule, a 55-ton locomotive which keeps unruly, oversized ships in line. It's history done my way, next on Guts and Bolts. Hi, I'm Tim Beggy. Right now I'm floating on the eighth wonder of the world, the Panama Canal. Almost 100 years after it's opened, it still impresses. But few really understand how it actually operates. So today on this special edition of Guts and Bolts, I'm going to take you for a ride along the path between the seas. Before there was a Panama Canal, ships had to sail 13,000 miles around the tip of South America to get from one ocean to another. The dream to build a shortcut dates back to the 16th century. The French were the first to try to capture that dream. They chose Panama, the narrowest strip of land separating the Atlantic and Pacific Oceans. In 1880, they grabbed their shovels and started digging what they wanted to become a 50-mile-long sea-level canal. 9 years, 22,000 deaths, and $250 million later, the French gave up. On May 4th, 1904, the Americans took over. But with a very different approach. They dammed existing rivers and flooded a 123 square mile area, creating the world's largest man-made lake, smack through the middle of Panama. The only problem, it was 85 feet above sea level. They needed a way to lift the ships up that high. Their solution? Locks. Massive concrete ship elevators, which they built on each end of the canal. On August 15, 1914, the completed canal opened. The American engineers did such a good job that today the canal still operates the same way as it did over 80 years ago. Now, thanks to the ingenious engineering of these special lock chambers, it makes it possible for these ships to cross over the Continental Divide 85 feet above sea level. Now, how do these ships levitate so effortlessly? Well, I'm going to find out from the Atlantic side superintendent of the Panama Canal, Mr. Abdul Perez.
Hi.
Good to see you, man.
Good to see you too.
So tell me, what is the main function of these locks?
Well, the locks are like stairways that we use to raise the ship. We bring the ship into the lock chambers, we close the gates behind them, and we fill the chamber using water from the upper lake just by using gravity. To go down on the other side, we do just the opposite. We lower the chambers by draining the culverts down to the ocean.
When the Panama Canal was built, locks were not a new concept. Far from it. They were invented by the Chinese in the 10th century, but no locks had ever been built at this scale. Here's how they work. When a ship enters the first lock, watertight gates close behind it, sealing the lock chamber. Next, water is emitted into the chamber from the lock above the ship. All this water is gravity-fed through giant valves and culverts, 18-foot diameter water tunnels, hidden inside the lock walls. The floating ship is then raised one step to the level of the next lock chamber. The gates upstream open to allow the ship to move forward. Once the ship has entered the next lock, the process repeats. The ship rises through 3 locks until it has reached the inland lake. The same thing happens at the other end of the canal, but this time, each lock is drained instead of filled. Once the ship is lowered 85 feet through 3 locks, it is back at sea level. Where do you control this from?
Everything is controlled from the control house.
Can we go check that out?
Yeah, sure, let's go.
All right. This is spectacular. Now, judging by the shape of this control panel, I'm guessing that this is in direct correlation with the locks.
Exactly, they actually represent the locks.
So what are some of the different features here?
Okay, for example, here we have the gate. This represents the gate, and these are the handles that are used for opening and closing the gates. These over here are the handles for moving the valves to allow the water into the chambers or to drain the chambers.
So what do we have here?
Okay, these are the stacks that show you the level of the water in each chamber.
And how much water does it take to move a ship from chamber to chamber?
Okay, the chambers are 1,000 feet long by 110 feet wide by about 81 feet tall. So we use a total of about 26 million gallons to raise a ship or to lower a ship every time.
Wow. Is the ship passing through now?
Yeah.
Would you mind if I move the gates?
No, in fact, we're ready to move these gates.
Really? Which
Yeah.
ones do I move?
This one, that
Here.
one, that one, and that one.
Which direction? That way?
That way.
Okay. Oh my God. I feel like a god. Now, is that roughly the same speed the gates are moving right now?
Yes, exactly the same speed.
Do you mind if we go down and get a better look?
No, we can take a look right now.
All right, vámonos. Wow, from this perspective, you can really see how giant these doors are.
Yes, they are.
How big are they?
Well, they are about 80 foot tall, average, 64 foot in diameter, and they weigh about 700 tons.
700 tons?
Yes.
If they're that heavy, how come they don't just topple over?
Well, actually, they are hollow gates. Inside, they're filled with air, and they actually float.
They're hollow.
Yeah.
Oh, that's wild. How old are these doors?
These are the original gates. They installed in 1914.
Wow. Now, how come it's at an angle like that?
The angle is for sealing purposes. This is a principle from Leonardo da Vinci's, the miter gate principle. With the pressure of water, the gates are tight against themselves and against the wall, so they seal very well, and that's how we hold the water.
And Da Vinci came up with that?
Yeah.
Too bad he's never been through the canal, huh?
No, sure not.
Now, what pushes the door in and out?
Well, actually, we use this arm down here,
Uh-huh.
which we recently installed. This is a hydraulic cylinder that pushes the gate in and out. Would you like to see how it works?
Yeah, I'd love to.
Okay, let's go.
So this is where the doors are powered.
Right.
And I'm guessing this is a hydraulic pressure.
That's right. This is a hydraulic cylinder that with hydraulic pressure pushes the gate out and in as we need.
How powerful?
That's a 60 horsepower motor.
60? That's
Yeah.
all?
That's all.
Doesn't seem like that much for a door that size.
You have to remember these gates are very heavy, so we have to move them very slowly. Then we don't need so much horsepower.
Wow, well, I think I got the gist. I think I understand the whole overview of how the canal works.
Oh, that's good.
I appreciate it. That's good timing, too. That's Captain Max calling me.
Okay.
So I don't want to miss the boat. I got to hop a ride. But thanks so much, okay? You want to come with me?
Nice seeing you. No, I'm
You gonna
sorry.
stay? All right.
Bye-bye.
Thanks,
Have a
man.
safe trip.
See ya.
Bye.
Captain Max is the man in charge of the Panama Canal's mighty tugboat fleet. And when Guts and Bolts returns, he'll let me get behind the wheel of one of these incredibly powerful machines. I'm standing here at the edge of the Panama Canal, where tugboats are essential in maneuvering ships from one ocean to the next. And they keep acquiring more raw energy and sheer agility. And no one knows this better than Captain Max Newman. He's in charge of the 24 tug fleet here at the canal.
Good morning, Tim.
How are you, Max?
Just fine.
Now tell me, what makes these tugs so special?
See, these tugs are equipped with powerful engines complemented by sophisticated propulsion units to provide adequate assistance to ships in and out of Panama Canal locks.
And they can really maneuver these
Oh
enormous
yes, they're
ships?
highly maneuverable, very powerful.
The original canal tugs were steam-powered, but as ships got bigger, the tugboats needed to toughen up. Diesel did the trick. Today's tugs have all the power and agility they need to hang with the big boys. The biggest of these ships are called Panamax. because they are built specifically to the maximum dimensions that can fit through the Panama Canal. When you need to position a 106-foot wide ship inside a 110-foot wide lock, you've got no room for mistakes. Tugs are responsible for guiding ships in and out of the locks and through the narrowest channels of the waterway. Beyond the usual forward and reverse, these tugs can push and pull sideways and turn on a dime. The source of their power and maneuverability is below the decks in the engine room, where Captain Max showed me around. Smells like power down here, Max.
A lot of power. There's a lot of power in here.
What kind of engine are we dealing with?
We have diesel power engines. This is a 1,500 horsepower engine.
And how many of them are there?
We have two of them, one for the starboard unit and the other one for the port unit.
So 3,000 total?
Yeah, 3,000 in total.
So what kind of system do the different tugs use?
Normally, ships and tugs are propelled by the use of propellers, like a fan blade. But this tug in particular is propelled by a Voigt-Schneider unit.
Why is it called Voigt-Schneider?
Voigt-Schneider designed these engines back in 1926. This is the unit itself, then the upper part, which we can only appreciate from the inside of the engine room. But we brought this model here to illustrate the underwater portion of it. The unit itself is fitted with 5 blades, as you can see here.
Oh, yeah.
And these 5 blades actually rotate in a vertical axis.
Point down.
They're pointing downward.
So you could spin them either forward or reverse.
Exactly. So you could move the entire tug in any direction by combining the angles of the blades of both propulsion units with the controls that the tugmaster has available in the wheelhouse.
Traditional propellers are mounted horizontally and can only thrust in 2 directions, forward and reverse, like a car. Imagine being able to drive your car sideways. That's what the Voigt-Schneider system can do. Here we can see the underside of a tug. There are 2 propulsion units side by side, each with 5 vertical blades that spin around like a giant egg beater. The pitch of each blade can be angled to push against the water during certain parts of their rotation, and angled back to slice through the water on the return stroke. The unique design of the Voigt-Schneider system allows it to thrust equally in any direction. So how does the awesome power of these tugs come to bear pushing and pulling the ships?
You see, at the end of the whole process, the tug can push with the use of fender rubbers, and it pulls with the use of the towing ropes.
How strong are these ropes?
These are made out of polyethylene, and they are capable of withstanding up to 353,000 pounds.
And how are they attached to the ship and the tug?
At the end of this rope, there is an eye that is fitted into the bit of the ship. And at the tug end, the line is fitted into the towing winch.
So are the winches controlled from down here?
On this particular tug, the winches are controlled from down here, but all the rest of the control, the maneuverability, and the power is up in the wheelhouse.
Let's pop up there.
Let's go.
So what's the most difficult maneuver?
Movement of the tug sideways is the one that requires the most practice.
Can you show me the functions?
Sure, sure. See, over here, we have the steering wheel and the throttles, and a combination of these components will control the Voigt-Schneider units. And this throttle over here is to control the engine's revolutions.
What you have for breakfast, Max?
Okay, as a matter of fact, scrambled eggs.
Yeah, how about a couple donuts? What do you think, huh?
Sure.
Come on.
Let me show you how this tug would form like a donut. If you move the steering wheel all the way to one side, you'll notice the tug moving actually like on a dime. And if I give it a little bit more engine revolutions, then we'll start doing it faster.
Boy, you can really feel it. You never know that we were spinning in circles, except for the fact that I'm about to barf. Can I take the helm?
Sure. Come on.
All right, what do I do here?
Okay.
I don't want a Mad Max.
Don't worry, you
pretty
can
good.
place your left hand on the wheel and your right hand on the throttles. And if you want to reduce the speed that is making you dizzy, you can reduce a little bit on the steering wheel.
Like that?
Exactly, just like that. Gently and smoothly as you're doing it, and you'll start feeling that the rate of movement is going to be gradually decreasing.
Can I move the throttles?
Sure, you can move the throttles.
Both of them at the same time?
Yeah, it's preferable if you move both at the same time. Go ahead, push them forward.
throttles up
Exactly,
here.
exactly. Now you want the tug to move that way, so you move the wheel this way.
Wheel over here.
Uh-huh. Go ahead, move
Throttle
it.
back here. Thanks, Max. I really appreciate the lesson.
For sure, sure.
Mighty kind of you, but
My
I
pleasure.
think I just ran over a duck, so you better take the helm again.
Okay.
Stay tuned, because up next we have another machine here at the canal that uses brute force. And believe it or not, it's called a mule. Welcome back to the Panama Canal. This man-made water system is responsible for passing 13,000 to 14,000 ships through it per year. And as you can see, they don't have much room to play with. So what keeps these ships from smashing these walls into smithereens? Well, they have to turn to another mode of transportation, a locomotive like this one right here. The locomotives essentially brake and steer ships while they're inside the locks. They're also called mules because historically, other canals use the actual animals to help guide ships. But at the Panama Canal, the mules have always been made of steel. Today's locomotives are virtually the same as the originals, except they're a lot stronger, faster, and more reliable. The superintendent of the canal's Atlantic locks, Abdiel Perez, agreed to show me how the locomotives work. Take me through the process. What's the first step?
Well, the first step is to get the cable on board. To do that, we tie up a rope to the end of the cable. We have this eye, and then the deckhands on top of the ship, they start pulling the cable on board.
Contrary to what you might think, mules don't actually pull ships through the locks. Ships navigate the canal under their own power. The problem is, they can't steer very well and don't have any brakes. The locomotive's job is to keep the ships in line and to help them stop. The average ship is assisted by 6 locomotives, each one attached to the vessel using 2 1-inch diameter cables. With just 12 cables, the strategically placed locomotives have complete control over even the largest of ships. By themselves, these 55-ton locomotives are no match for a 70,000-ton ship, which could easily yank a mule into the canal. Mules get the upper hand from a key ingredient, a specially designed rail system.
This is the track system. First, we have the running rails here. They support the weight of the locomotive. Between the running rails, we have this rack rail. This serves two purposes: to provide the traction, because this system is engaged by a pinion in the locomotive. And it also is engaged by the safety wheels on the sides because it has a V shape. Okay? That prevents the locomotive from overturning.
So just right here is secure enough to keep it from falling into the canal.
Exactly.
Here you can clearly see how it works. The fixed rack rail is the traction platform for the locomotive's pinion gear, while the safety wheels hug the undersides of the rack rail to provide stability under high cable tension. Oh, I see what you're saying now. So this is the gear that actually propels the whole locomotive forward.
Exactly.
And do these keep it attached?
Right, we call these safety wheels, and they attach to the sides of the rack rail, and they keep the locomotive from overturning.
While running along the rack rail, the pinion gear is driven by 2 290 horsepower electric motors, which provide braking power from the locomotive to the ship. All that power comes to the motors through a 480-volt third rail embedded along the tracks. It's all controlled from the locomotive cab, where I climbed in for a look.
Okay, this is the operator's cab.
Okay. Oh man, it's really cool. I mean, literally, it's
Yeah.
air conditioned.
Yes,
Nice.
it is.
So explain this to me.
Definitely. These are the controls for the winches. One for each winch. This is for the left hand, this is for the right hand. If you push it up, you release the cable. If you pull it down, you pull the cable. Very simple. And here you have the gauges. You have to watch for the tension on the cable.
Can you run both cables at the same time?
Yes, you can.
Yeah.
On the other side, you have the controls for the proportion. If you push forward this lever, you move the locomotive forward. If you pull it down, then you brake it.
How do you change directions?
Well, you use that button there, left
Okay.
or right.
All right. Would you mind if I took it for a spin?
Yeah, you can do it.
Really? Can I?
Sure.
All right then. Cookie Kid, clear the track. Put it up to where?
H.
We moving? Here we go.
There you go.
All right. How do you steer it?
Come on, you're on rails. You don't need steering here.
right. Out of the way! Can I toot the horn?
Go ahead.
Woo!
Okay.
Excuse me.
We have to be careful with that because that's our signal for the lockmaster that we have problems.
Oh boy.
So pretty soon we're going to be chased by mechanics and electricians.
Okay, sorry about that.
No
I'm
problem.
always causing problems.
How does it feel?
Feels great. I really appreciate you having me here and teaching me how to do this and letting me operate a train.
Great.
I never thought I'd be driving a train, let alone at the Panama Canal. I really appreciate it, Mr. Perez.
Sure, you're very much welcome.
Thanks for having me.
Thanks for tuning in to this special edition of Guts and Bolts. We'll see you next time.
It's the Cookie Kid. I'm closing the lid.